The definition of a binary operation, the name itself suggests us that we should have two elements with us in order to perform this operation. Therefore, it is called as a binary operation, right? So the definition says we should have a non-empty set, obviously, otherwise there is no meaning to the definition. So if G is a non-empty set, then star on set G will be a binary operation if star from G cross G to G is a function. Remember, star will be binary operation on set G if the star from G cross G to G is a function. So domain is G cross G and the codomain is G. Now talking about G cross G, this is called as Cartesian product of G with G, right? You might know the concept of A cross B. This is called as a Cartesian product of A with B, where the first element is taken from set A and the second element is taken from set B, like this. For example, my set G is 1, 0, minus 1. So what will be my G cross G? So the first coordinate should be from G as well as the second coordinate should be from G. So the possibilities are, first of all, we'll fix 1 in the first coordinate and we'll vary the rest of the elements. So it will be 1, 1, 1, 0, 1, minus 1. Now we will fix the another element of G, that is 0, and vary the other elements of G in the second coordinate. So in similar way, we can do it for minus 1 also. And we are having a formula, right, in order to guess the order of G cross G, and that is nothing but mod of G multiplied by mod of G. That is number of elements of G multiplied by number of elements of G. So in this case, the number of elements in G are 3. So the number of elements in G cross G should be 9, right? As you count, these are exactly 9 elements. Now, in order to check whether plus is a binary operation on set G, what we are supposed to check? According to the definition of binary operation, this plus from G cross G to G should be a function. So I have already calculated G cross G for you. Now just we have to find the images, right? So what will be image of 1, 1? So the binary operation is plus, right? So image of 1, 1 will be 2. Just I am adding the coordinates because the question is asked whether plus is a binary operation, right? Next, 1 plus 0 is 1. Again adding it, 0. This will give me 1. This will give me 0. This will give me minus 1. This will give me 0. This will give me minus 1. And this will give me minus 2. Now the question is, all these are images of the elements. So every element in the domain is having an image here, as you can see. Further, the image is unique also. But the question is, whatever image we have found out, whether it lies in codomain or not. There is no. As you can observe, the image of minus 1 is minus 2, but that is not present in G, right? And therefore, this plus is not a binary operation on this set G. Moving towards the next example, here the set G is given to be 1 minus 1, and the question is asked whether multiplication is a binary operation. So again, in this case, we can find the domain, right? So G cross G will be actually equal to, now first of all we'll fix first coordinate to 1 and we'll vary the second coordinate. So 1, 1, 1 minus 1. Now we'll take the first coordinate as minus 1 and we'll vary the others. So since the question is asked whether multiplication is a binary operation, so we are supposed to take multiplication of this coordinate. So 1 multiplied by 1 is 1. 1 multiplied by minus 1, yeah, this is minus 1, this is minus 1, and this is 1. Now the question is the criteria of the binary operation satisfied? What is the definition saying? That this multiplication from G cross G to G should be a function. Then and then only this multiplication will be a binary operation on set G. As we can observe, all the elements do have images. They are unique also because each and every element is having exactly one image. But the question is whether the images lies in codomain. Remember, codomain is G, and the answer is yes, because the elements are either 1 or minus 1 and that line G. So therefore this is a binary operation. Now what happens is when the set is finite, we can calculate G cross G, right? But if the set becomes infinite, then it is very difficult for us to find entire domain that is G cross G. So we are supposed to understand the logic first. What is going on here? So for that, let me draw one table for you. So there is one more way to check whether uh, given operation is a binary operation or not. And this is especially for finite sets. For infinite sets, I will tell you what to do. Uh, Now here, since our set is G, let us write down all the elements of G. That is 1 minus 1, 1 here, and minus 1 here. Now the operation is multiplication. We have to just complete this table. Yeah, the table here. So 1 multiplied by 1 is actually 1. 1 multiplied by minus 1 is minus 1. Minus 1 multiplied by 1 is minus 1, and this is going to be 1. So what we have to check, the entries of the table should be from G only. If that is happening, then directly we can conclude that this multiplication is a binary operation, right? Now if the same thing I do for plus, then what will happen? Let us say this is 1, this is minus 1, 1, and minus 1. Now the binary operation is plus, so 1 plus 1, 2. I mean the operation is plus. Okay, we are checking it whether it is a binary operation, right? So 1 minus 1, 0. This is 0 and this is minus 2. So the operation here is plus, and as we can see, the entries in this table actually are not from the set G, right? Because G has only 1 minus 1, and here I got 2, 0 and minus 2. So therefore sum means addition is not going to be a binary operation on this set G. This is a one more way. If you are finding difficult to find G cross G and then finding the images, then directly you can draw this composition table, and from the composition table you can decide whether the given operation is a binary operation or not. Now remember, this applies only if the sets are finite. So in order to understand the definition for infinite sets, we are supposed to understand the logic behind it. What exactly is going on in order to check whether the operation is a binary operation or not. So the idea here is, there is a simple idea. You take any two elements of the set G, repetition is allowed. Remember, as you can see, 1 multiplied by 1 is there, right? This is from G, this is also from G. So you take two elements from G, repetition is allowed, and whatever operation is given, just you perform the operation on that two elements. And if whatever outcome you get, if that outcome lies in G again, then that operation will be called as a binary operation. For example, let us try to see this one. So the question is asked whether this subtraction is a binary operation or not. So in order to check it, I will take two elements of set of natural numbers. Any two elements. Remember, repetition is allowed. So if I take 2 and 3, and if I calculate 2 minus 3, I will get it as minus 1. Does it lie in set of natural numbers? Answer is no. Therefore, the subtraction is actually not a binary operation in set G. And uh, if you feel that after taking any two elements of the set G, uh, whatever operation is given, and if you perform that operation on that two elements, and again if you get an element of the set G, then that operation will be called as a binary operation. For example, let us talk about the operation plus on set of natural numbers. Now if you take any two natural numbers, we already know that if you add the two natural numbers, the answer is again going to be a natural number, right? For example, if you take 5, 10, 15, again a natural number, and this is applicable to any two natural numbers that you pick. Repetition is allowed, obviously. Still, the outcome will be a natural number, so therefore this plus is a binary operation on set G. Similarly, will happen for multiplication also, because if you take any two natural numbers, the multiplication will again be a natural number only. So this fourth one, I leave it to you. You can check on your own whether uh, this plus, minus, and multiplication are binary operations on this set of integers or not. Moving towards the final example, here my G is a set of natural numbers. Now we have to check whether this operation given, that is star, is a binary operation on this set of natural numbers or not. Again, we have to pick two elements from set of natural numbers. Uh, let us say I pick 1 and 1, as repetition is allowed, right? So what will be my 1 star 1? If I calculate it, it will be equal to 1 plus 1, right? Minus 5, because what the operation says, m star n is actually, you simply take the addition of m and n and subtract 5 from that. So 1 plus 1 is 2, and minus 5 will be minus 3. So does this lie in set of natural numbers? No. So therefore, is it a binary operation? No.